All right, so today we're going to discuss simulations. Simulations is a tactic in statistics or a process in statistics that you create many population proportions, sample proportions over the course of a period of time to indicate whether information is valid or not, I guess. So I brought in a 6-sided die for each person at school. If each person rolled the die 50 times and kept track of how many times a 5 appeared, okay, this is a simulation. Each person found the sample proportion for the data. So they did how many 5s over 50, and we plotted it. So some people only got 10% of a 5. Some people got 39%. So this is an idea of a simulation where we roll the die a whole bunch of times, and each one of these is a different proportion. It's an example of a different sampling that occurred. So then it's basically just a way to draw more accurate conclusions and to just have a lot more data. So then more data means more accurate conclusions. Okay, what was the smallest sample proportion? This one with this dot, that's the smallest. So that means 10% was the smallest amount of time, a 5 appeared. The largest would be up here, 0.39. Which one occurred the most often? Well, these little dots are how many times they occurred. So 0.24. And using your calculator, find the mean. Okay, this is a bit an excessive amount of work. I just did it so that I would have an answer. I'm just going to round. I'm just going to make it a statement because I didn't write it on here. I'm going to round everything to the 10,000ths. Okay, so that's 4 decimal places. Now, if you had to do this yourself, I realize I have wishful thinking to think that you would do this right now. But the idea is you would have an L1, L2. This is one variable statistics, kind of a review of that. All of these values at the bottom would be an L1. So 0.11, 10, 12, 14, 16, etc. And these little dots here, that's how many times they occurred. So there's 1.10, 0.12, there's 2 of them, 0.4, there's 3, 1.16, whatever, you know what I'm talking about, is 3, and etc. All the way down to 0.3, not 39. This should have been 40. I'm sorry, 0.40. All the way down to 0.40. I did it right when I did it, so that's good. There's 2 of them in that one. So you would plug all those in. I plugged them all in. I'm going to go to the nearest 10,000. I did my one variable statistics. So remember that's stat calc choice 1. And that's one variable statistics. For L1, you put it in the first spot, and L2 for the frequency. So that's how many times it occurred. When I did that, I got 0.2466 for the mean and 0.0616 for the standard deviation. So about 25%, the 5 came up is the average, and the standard deviation is about 6% there. So how many people stayed after? Well, that's just how many dots there are up here. And when I did it, I counted 100. What is the margin of error? Well, there's a few ways we could do the margin of error, but the easiest route would be 2 times the standard deviation. So the standard deviation is 0.0616. So the actual 2 times that would be 0.123. I guess in this case it would be 2, because when I did it I didn't round, so mine are a little bit more accurate, but in this case if I actually doubled this is what I would get. Okay, now what is the confidence interval? Well, we already know what the mean is up here, so we figured out the mean. The mean is 0.2466, so we're just adding the margin of error and 2466, and we're subtracting that margin of error. So that would be 0.1233 and 0.3699. So that's what I got. Mine's a little bit more accurate, so maybe it's slightly different if I actually use these numbers. So this is the confidence interval here, so anything that falls within here is probably a good estimate of how many times a 5 will occur on a die. So anywhere between 12% and 37%. So if we look here on the back, excuse me, if we look here on the back, you'll notice that they're asking how does the mean sampling distribution. So if someone else came in and got 0.23, do you think they have a real die, or do you think it's a fake, like a weighted die where a 5 maybe occurs more than not? Well, this is a good prediction or a good die, 0.23. Okay, because it falls in the confidence interval. I can't go backwards, but if you just look on the other side, 0.23 is between 0.1233 and 0.3699. So it falls within that in the confidence interval. What do you think would happen to the variability, the standard deviation, if the distribution of the sample proportion size for each sample was 200 instead of 50? So all that means is whenever all the 100 people came in for extra help, because that's really an accurate number right there, if all those people rolled the die 200 times. And what happens whenever you have a higher or bigger sample, the standard deviation gets smaller. And remember, since standard deviation is a measure of how spread out things are, that means that all of the data will be closer together. So the higher a sampling, the smaller the standard deviation, and the more accurate the data. All right, have a good day.